Imagine holding a tiny green pea in your hand. It seems so simple, so ordinary, just a small round seed easily overlooked. But what if I told you that within this humble pea lies a universe more vast and mysterious than you could ever imagine? Now shrink yourself down to the scale of a single atom inside that pea. Suddenly the world you know dissolves, replaced by a landscape so alien it defies belief. The surface of the pea becomes a sprawling terrain, and you find yourself surrounded by the building blocks of everything, atoms, the fundamental units of matter. If we magnified one atom to the size of a cathedral, its nucleus would be a grain of sand at the center. Everything else, vast emptiness. The nucleus, tiny and dense, sits alone in the middle while the rest of the cathedral is almost entirely empty space. It's as if the solid world we know is built on a foundation of nothingness. The electrons? They'd be like dust motes, barely visible, zipping around the distant rafters. They move so quickly and unpredictably that their exact position is never certain, only a cloud of possibility. These tiny particles define the boundaries of the atom, yet they are so far from the nucleus that the emptiness between them is almost unimaginable. Nearly all the solid matter you know is actually empty space. The atoms that make up your body, the chair you sit on, and the air you breathe are mostly void, with only minuscule bits of matter suspended in a sea of nothingness. The world feels solid, but it's an illusion. Particles are so small and so far apart that emptiness dominates. What we perceive as hardness or resistance is really the result of invisible forces, not tightly packed matter. The atoms in your hand never truly touch the atoms in the wall. Instead, they repel each other through powerful electromagnetic forces. When you clap your hands or lean against a wall, you're interacting with structured emptiness. The sensation of contact is the result of these atomic forces pushing back, creating the illusion of solidity where in reality, there is mostly space. The sensation of solidity comes not from packed matter but from invisible forces acting across these immense atomic voids. It's a dance of energy and probability, where the boundaries of objects are defined not by substance, but by the interplay of forces at the quantum level. So next time you pick up an apple, remember, you're holding a universe of emptiness, shaped by forces, not substance. Every object you touch, every surface you feel is a delicate balance of energy fields, not a solid block of matter. The apple in your hand is a marvel of structured nothingness, held together by the invisible rules of physics. The journey into the heart of matter begins here, where reality is stranger than it seems. The deeper we look, the more we realize that the universe is built on paradoxes. Solidity from emptiness, certainty from uncertainty, and order from chaos. The world of our senses is just the surface. Beneath lies the bizarre realm of quantum mechanics. Here particles can be in many places at once and the rules of everyday life no longer apply. It's a place where our intuition fails, and only the language of science can guide us. Welcome to the Cathedral in a Pea, a place where the ordinary becomes extraordinary, and the smallest things reveal the greatest mysteries of the universe. What are atoms? They're the invisible foundation of everything you've ever seen, touched, or imagined. But what are they, really? To answer that, we have to travel back in time to the very beginnings of human curiosity. The word comes from the Greek atomos, meaning indivisible. Ancient philosophers wondered if matter could be divided forever, or if there was a smallest possible piece. For centuries we imagined atoms as solid, unbreakable marbles, the ultimate building blocks. They were thought to be the tiniest, most fundamental pieces of the universe, like cosmic Lego bricks. But science revealed a deeper truth. Atoms have structure, more like tiny solar systems than marbles. Electrons whirl around a dense center, much like planets orbiting a sun. They're made of even smaller parts, protons, neutrons, and electrons. Each of these particles has its own unique properties and roles working together to form the atom's identity. This discovery shattered the idea of the uncuttable atom. Suddenly, the universe seemed even more complex and mysterious. Atoms are the basic units of elements, hydrogen, oxygen, gold, each defined by its unique combination of these particles. The number of protons in the nucleus decides what element an atom becomes. Everything you see is built from these atomic letters arranged in endless combinations. From the air you breathe to the screen you're watching, atoms are everywhere, forming the world's infinite variety. A single drop of water contains more atoms than stars in the Milky Way. Imagine the vastness of space, then realize that even the tiniest drop holds a universe within. A grain of sand holds more atoms than all the grains of sand on Earth's beaches. The scale is almost impossible to grasp. Atoms are so small yet so numerous they defy our imagination. Atoms are astonishingly small, yet they shape the universe. Every star, planet, and living thing is made from these minuscule wonders. Their most shocking secret? They're almost entirely empty space. If the nucleus were the size of a pea, the nearest electron would be hundreds of meters away. The universe is built on a foundation of nothingness. What feels solid is mostly void, with tiny particles dancing in the emptiness. The real magic is in how these empty structures combine to create everything we know. Atoms link up, forming molecules, and those molecules build the world. Atoms are the architects of reality, masters of emptiness, weaving the fabric of existence from almost nothing at all. Let's meet the atom's residents: protons, neutrons, and electrons. At the center, protons and neutrons cluster tightly in the nucleus, a dense heart of matter. Protons are positively charged, neutrons are neutral, acting as glue. The number of protons defines the element. Hydrogen has 1, carbon 6, gold 79. Orbiting far from the nucleus are electrons, tiny, negatively charged, and much lighter. The attraction between positive protons and negative electrons holds the atom together. In a neutral atom, protons and electrons balance each other's charge. This simple structure, nucleus and electron cloud, underpins all chemistry and biology. The periodic table is just a map of how these particles arrange themselves. The dance of protons, neutrons, and electrons creates the complexity of the universe. Every object, every living thing is built from this elegant atomic choreography. The universe's diversity springs from these three tiny players. To grasp atomic emptiness, picture this. If a proton were a basketball at midfield, its electron would be a speck orbiting in the stadium's parking lot. The entire stadium, between proton and electron, is empty space. The particles themselves occupy a minuscule fraction of the atom's volume. If you removed all the empty space from every human, humanity would fit into a sugar cube. Matter is over 99.9999999% empty space. Solidity is an illusion, created by the behavior of particles in this void. The universe is a web of particles separated by immense gulfs of nothingness. Even stars and galaxies are mostly empty, both between and within them. From cosmic scales to atoms, emptiness is the rule. Our existence is a flicker of substance in a vast ocean of void. If everything is mostly empty space, why can't you walk through walls? The answer isn't about atoms bumping together, it's about force. When you press your hand to a wall, the atoms never actually touch. What you feel is the electromagnetic force. Electrons in your hand repel electrons in the wall, like charges repel, just as magnets push apart. As you get close, this repulsion becomes incredibly strong, creating an invisible barrier. You've never truly touched anything, you only feel the force field. Solidity is the sensation of electromagnetic repulsion, not contact. The chair holds you up with this force, not with substance. You're floating on a cushion of electromagnetism. To understand this invisible shield, we enter the world of quantum mechanics. On the atomic scale, particles don't behave like tiny billiard balls. They're unpredictable, governed by probability. The force you feel when touching something is explained by the exchange of particles. Imagine two people on ice skates throwing a ball back and forth. The act pushes them apart. In quantum terms, the ball is a photon, the same particle as light, but here, a virtual photon. When electron clouds approach, they exchange virtual photons, creating a powerful repulsive force. This is the electromagnetic force at work. All forces, electromagnetism, the strong and weak nuclear forces, are carried by specific particles. The world is a dynamic sea of energy fields and virtual particles, not just empty space. Reality is a constant interplay of invisible forces. The illusion of solidity is built on this quantum exchange. Let's zoom in on electrons, the dust motes of the atom. The old model pictured electrons orbiting like planets, but quantum mechanics says otherwise. Electrons aren't points in space, they're smeared out in clouds of probability. We can't pinpoint their location, only the chance of finding them somewhere. These electron clouds have distinct shapes, spheres, dumbbells, even flower-like patterns. The arrangement of these clouds determines how atoms bond and form molecules. Chemistry is the study of how these fuzzy clouds interact. When your hand nears a wall, it's not point-like electrons repelling each other, it's overlapping probability clouds. The repulsion you feel is the interaction of these ghostly fields. The solid world is built on the dance of uncertain ethereal electron clouds. Tangibility arises from the quantum dance of probability. Reality is shaped by the interactions of these invisible clouds. There's a quantum rule that shapes the very fabric of matter, one that determines why the world is the way it is. It's called the Pauli exclusion principle, and it's one of the most fundamental laws in all of physics. This principle states that no two electrons can occupy the same quantum state in the same place at the same time. In other words, each electron in an atom must have its own unique set of quantum numbers, like a cosmic fingerprint. Imagine a movie theater where every seat is reserved. No two people can sit in the same seat at once. The Pauli exclusion principle is like a universal rule of personal space for electrons, ensuring each one has its own seat in the atom. As you add more electrons to an atom, they're forced to occupy different energy levels, filling up shells further and further from the nucleus. This stacking effect is what gives atoms their unique structure and size. The Pauli exclusion principle is the reason atoms don't collapse into a single point. It's what gives matter its volume, its shape, and its ability to form the complex structures we see all around us. Without this rule, all electrons would fall into the lowest energy state, and atoms would shrink down to tiny, indistinguishable points. The universe would be unrecognizable, featureless, flat, and lifeless. No chemistry would be possible, no molecules could form. Life, as we know it, would simply not exist. The diversity of matter, from the air we breathe to the DNA in our cells, all depends on this quantum rule. When you try to push your hand through a wall, you're not just fighting electromagnetic repulsion, you're also up against the Pauli exclusion principle, which prevents the electrons in your hand from occupying the same states as those in the wall. The electrons in your atoms are forbidden from sharing the same quantum state as the electrons in the wall. This invisible barrier is what keeps you from passing through solid objects. The universe enforces this rule with immense resistance, making matter feel solid and impenetrable. Even the strongest machines can't overcome this quantum law. This is why matter feels solid, why objects take up space, and why you can lean against a wall without falling through it. The solidity of the world is a direct result of the Pauli exclusion principle. The Pauli exclusion principle is more than just a rule for electrons. It's the quantum law that gives the universe its substance, its structure, and its very existence. So the next time you bump into a wall, remember, it's not just solid matter stopping you. It's a deep, invisible quantum law, the ultimate reason you can't walk through walls. We've journeyed from a pea to the heart of the atom and found the universe is not what it seems. The solid world is a grand illusion, particles separated by vast emptiness held together by invisible forces and quantum rules. You are mostly empty space, sitting on a chair of empty space in a room of empty space. This challenges our sense of reality. Our senses evolved for survival, not for perceiving the quantum world. Science lets us peek behind the curtain and glimpse the truth. You are a self-aware pattern of energy and information, a structure of organized emptiness. The emptiness inside your atoms is the same as that between the stars. You are connected to the universe in a profound way. If matter is mostly empty space and force fields, what does it mean to be real? The search for that answer is the ultimate adventure, a journey to the edge of knowledge, into the beautiful emptiness